Okay, so these are the objectives we'll go through today. Search, circle, trigo, differentiation, integration. And then after that, we'll do proving of geometry. Then we'll do a revision of linear law. So if revision of linear law, if we can finish it, if we can clear everything, when I say everything means all those that I'm going to highlight. If I can clear this, and this, then good. That means that I will have time to do revision of linear law. But if I cannot clear all this, then revision of linear law will be next lesson. But revision of linear law, I can only do the non-drawing question because the drawing question must be in person. Yeah, it's very hard to do the drawing one over online because I cannot tell you exactly whether your drawing is right or wrong, okay? And I cannot use a ruler over the screen to show you guys. Yeah. Okay, so that's about it. So maybe before we start, can you all do a vote, okay? Vote on the Zoom chat. Do you all want to do corrections first from the Math Munchies book, or do you want to do the learning first? So Zoom chat me your option. What do you all prefer? Okay, got your... Ayo, everybody choose learning because nobody do their homework, is it? Is it you all never do homework?
I did so early on Wednesday, Tuesday.
Then how come don't go through questions? Want to do learning first? May I know why?
Correction will take very long. So if we learn first, then do correction like better.
Okay lah. All right. Let's go to learning or proving of geometry. Now, proving of geometry, can you guys go and refer to your AMATH notes, okay? We need a few things. Number one, you need your set 1 angle notes. But I know that all of you all never learned set 1 under me. So I believe I gave you guys this note called angles. Have or don't have? Okay, if you have, can you take a picture and send it to the group chat? Then I know that that is the angles notes that you all need to have. Yeah, you all need to have that. Number 2, you need to have your set 3 circles notes. Okay, these are the 2 things you guys need. So can you all go and find that now? Take a picture and send it to the group chat. Then I know that, okay, you all have these 2 notes. Then we can do some add-on and can clarify certain questions in there. The notes, I can clarify on that. So take a picture and send it to the group chat, and then I know you are ready. Okay, guys, so right now, right, if you look at your angles notes, the one that is the back page about the squares, the rhombus, the rectangle, right? So all those notes, I will go more in depth today. So if let's say you got no space to fill it in, then you can write it on a separate piece of paper. So all those notes that you send me, make sure that you have an extra copy to put it in your AMATH file. Okay? Now, when you do proving of geometry, there are 2 new concepts that I would want to teach you guys. So what are the 2 new concepts? Okay, so all these, right? Later we'll go more in depth, okay? So all these, I hope that you all have printed it out already. Have you all printed it out, guys?
Yes.
Yeah.
I only can hear Shruti and Qiyuan. So YC?
Yes.
Okay, very good. So all of you all have printed it out. So these are the notes that will fill it, put it in your AMATH file, okay? So before we move on, why I don't want to go through much in depth in this, because this one we have already done in set 1, set 2, but later I will do a recap with you guys. So if you look at my next page, these are equivalent conditions. There's one thing I want to teach you guys. It's the circles one and the midpoint theorem. Okay, so let's start with the one in the circles because this is what you all are familiar with. So can you see that all these are all very familiar things that you all have already known from your AMATH circles, guys?
Yeah.
Nothing new, right? Okay, but there is something new that, remember last year I taught you guys, if you look at your notes, can you see this thing called the alternate segment theorem? Can you all find it?
Yes.
Yeah, I'm gonna pause the video and I want you all to show me where is it on your notes. Okay, what about this alternate segment theorem if you look at your notes? So alternate segment theorem is basically, can you see this is a circle? So when you have a circle, you need to be very careful. So usually we are trained to do quadrilateral, but right now we have a triangle. Can you see that? So now this triangle is touching at all the sides of a circle. That must be on the circumference of the circle, okay? So that is the first condition. So the triangle must be on the circumference. Now, the next part is you must have this thing called the tangent. Okay, you must have this thing
Can I go and get a piece of thin paper?
Yeah. So number 2, you must have a tangent. Okay, then I must wait for Qiyuan because the next part I'm going to say is very important. So when Qiyuan is back, I'll continue. Now, what's so important about this alternate segment theorem is can you see that in this triangle, we have 3 angles. We have the green one, we have the pink one, and we have the blue one. Do you all agree? Yes or no?
Yes.
Now,
Yes.
when we want to do this alternate segment theorem, it can get really confusing. So, right, what is the trick? The tip that you guys can use is that always identify the green angle first. Okay? Why? Why always identify the green angle first? Now, how to identify the green angle? The green angle is in the triangle that is touching the tangent. Are you all with me so far?
Yes.
Yeah.
So now, how do we find the blue angle? Because it's called alternate, right? So if this is the blue, means from here, the side of the triangle, all the way until the line. I repeat, if you're not listening. So can you see the side of the triangle? All the way until the line. Until this line here. This whole thing is also blue. For example, if this person is 30 degrees, means this person is 30 degrees. Okay? Then next up, we have this. Okay, maybe it doesn't make sense to be 30. Let's make it into 80 degrees and 80 degrees. So the next one is the one in pink. So the one in pink is here, right? So the one in pink right here, if it's this person is, for example, 50 degrees, means this angle here is 50 degrees. And that is how you use alternate segment theorem. Got it?
Yes.
Yeah, so that's it. So the next concept I'll teach you guys is midpoint theorem. So I would actually say that only these two are something new that you guys might not know, but the rest are everything you have learned from set 1 to set 3. So it's like a big recap or a condensation of all the concepts you all have learned from set 1 to set 3. So I give you all some time to copy first. When you are done, I'm going to move on to the next concept called midpoint theorem. All right, guys. So right now, we'll be doing this thing called the midpoint theorem that you can write it on your piece of paper that just now we're writing halfway for the alternate segment. So now, midpoint theorem, right? This triangle looks like like a mountain with snow. Okay, so it looks like a mountain with a snow. Or it looks like what? Like a candy. There's one candy that look like that. It's orange in color one. Have you all had it before?
It's orange and yellow.
Yeah, it's like orange here, and then after that yellow here.
I think like corn cobs or something.
Okay. But just remember, okay, so if you want to do it, just remember that it is like a mountain or a pyramid. Okay, so for me, I treat it more like a mountain. So what happens is that we have triangle ABC. So how to use midpoint theorem? So midpoint theorem is when they say that, for example, can you see the new points D and E? If they tell you that D and E are the midpoints of AB and AC. Now, guys, I want to ask you, for length AE, can I draw double line? Yes or no? Can I draw double lines?
No.
No, so it's only single line, okay? So now, the moment they tell you that D is a midpoint of AB and E is a midpoint of AC, we can derive two things. The first thing we can derive is that DE will be parallel to BC. You understand? So what does it mean for it to be parallel? For it to be parallel, that means that we know that this angle is equal to this angle, and we know that this angle is equal to this angle. Got it so far? So it's similar to what you all learned in similarity triangles. Now, another thing we can form, number 2, is that we can say that the length of DE is actually half of BC. Now, how do they derive this? It's also same with similar triangle. Do you all remember similar triangle? Because I know that this is 1 unit, 1 unit, 1 unit, 1 unit. Correct or not, guys?
Yes.
So we know that this triangle, remember I told you all the 3 different techniques, the pizza method,
Yeah.
last
Pyramid.
method.
Hourglass.
Correct, very good. So this is the pyramid method, correct? Whereby these two are parallel. So a parallel means I can draw it separately. The small one will be 1U, 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 and the big one will be
2U.
2U and 2U. So therefore, I can say that DE is actually half of BC because DE is 1 unit and BC is 2 units. You all got it? Understand?
Yeah.
So with that, y'all can fill it into your notes about the midpoint theorem. Then we're going to do a few questions. Okay, and then that's all for this chapter. Okay, now for this page, right, I believe you all have already known the properties like opposite angles of a parallelograms are equal and all those, right? So all this basically you need to like memorize and you need to be very familiar with all these properties. But there's one property that not many students will know. That is the thing called diagonal. You all know as diagonal, right?
Yeah.
Diagonal is this one, the one that I'm going to highlight all in pink. So these are all the diagonals. The diagonals, the diagonals, and the diagonals. So be very careful, okay? Only for rhombus, square, and kite, remember these 3, only these 3, the diagonals will bisect each other at right angles. Okay, only for these 3. Yeah, why this one so extra, this kite thing? Okay, they say diagonals are perpendicular means it's the same thing, okay? They tell you that it is right angle. But why this person, right, never say bisect each other? Now, I'm going to explain to you all. Okay, so I take back my words. It's not so extra. There's a reason why. So this one, they actually put 2 properties in one. They say the diagonal. Wait, let me highlight it. Can you see the diagonals? They say at right angle, right? They form right angle. Agree, guys? Correct or not? Can you see
Yeah.
right angle, right angle. That's why they're perpendicular. But for rhombus and square, they have one more special one for the diagonals. For rhombus and square, the diagonals will bisect each other at right angles. Also for square, there's bisect each other at right angle. Means they're telling you that this and this will be equal. These 2 lengths and these 2 lengths will be equal. And then this and this and this and these are all equal. But for kite, they never say bisect. Why? Can you see only one diagonal is equal, the other is not? Correct?
Yeah.
So can you see for rectangle and parallelogram, the diagonal also bisect each other. Bisect, 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 bisect. Okay? But they don't form right angle. So I repeat again now. For diagonals, parallelogram, rectangle, and rhombus and square, these four will all bisect each other. Okay, bisect each other means they form equal lengths when they cut each other. So when the intersection point, right, it will cut into two equal lengths. That's what bisect means. But for the one in blue, which means the diagonals for these two, on the other hand, will give you 90 degrees. 90 degrees means they're perpendicular at the intersecting diagonals. You all get it now? Can you see the difference?
Yes.
So with that, you all can make your notes. I give you all some time. Let me know when you are done. So for this word example 5, I will need you guys to start highlighting. So first thing first is they say that there is a quadrilateral QUAD. So this is Q, U, A, and D. Quadrilateral means four-sided figure. And they say that it has an inscribed quadrilateral or PROF. Inscribed means it is fitted nicely inside, whereby the edges will touch the quadrilateral. Okay, that's what inscribed means. So over here, we have midpoint. Okay, so when I see midpoint means in my head, I'm thinking, okay, is there a possibility that there can be a midpoint theorem? So I will continue. They say that, oh, P is a midpoint of QD. P is a midpoint of QD. So I know that this and this are equal. So I'll highlight it. This and this are equal. Next, I'll change color. They tell me that R is a midpoint of QU. R is a midpoint of QU. Okay, over here, midpoint, midpoint. Next up, they say that O is a midpoint of UA. O is a midpoint of UA. Okay, so 1, 2, 3, 1, 2, 3, and the last one, the one in blue, the F is a midpoint of DA. Means these two and these two are equal. All right. Now, they say that proof that the quadrilateral of PROF, means the one in red, is a parallelogram. So for it to be a parallelogram means you need to understand that we need to prove that there are two parallel lines. Understand, guys?
Yes.
So we need to prove that this is parallel to this and this is parallel to this. So how do we go about proving? We can use midpoint theorem already. Why? Because to prove that this is parallel to this, right? Can you see that over here? Okay, so this example is good enough. I will use this one. P is a midpoint of QD, right? We all know that P is a midpoint of QD. It's the one in orange. And we also know that R is a midpoint of QU that we learned just now. So I'm going to draw out the triangle for you separately. We have Q, we have D, we have U, we have R, and we have P. So remember just now we learned if this is midpoint with this, and this is equal to this, therefore we know that this is parallel to this. Agree or not, guys?
Yes.
That's why
Yeah.
they say that by midpoint theorem, I know that PR is parallel to DU. So this one here is parallel to this one here. Okay, got it. Next, the next one they tell me is that F is a midpoint of DA. Wait, sorry, F is in blue. So it's in blue. F is a midpoint of DA. and O is in green, is a midpoint of UA. So it's the same thing already. So if we know by midpoint theorem, therefore we can say that what? Who is parallel to who? Because right now we are focusing on this triangle now. So who is parallel to who?
FO parallel to DU.
Yeah, so far you all understand now? So if we know that if PR is parallel to DU and FO is parallel to DU, and DU being the common parallel lines, so therefore we can say that by midpoint theorem, they say that PF is parallel to RO. Why? How come they know? Because, right, this is all midpoints, right? We already derived this person and we know that PR is parallel to FO. So same thing, if I'm going to erase all these purple ones, and right now I focus the same way of doing to this purple one. Can you see here the purple triangle now? We know that RO will be parallel to QA and PF will be parallel to QA. Therefore, you can say that similarly, if these are all the midpoint, which is the repeat of this first part, we can then derive that using the midpoint theorem, we can say that PF is parallel to RO. And with that, since we know that we have one parallel lines and two parallel lines, we can say that PRO is a parallelogram. And that's it for using midpoint theorem in this kind of a question. All right, so just now remember I was telling you guys about if it's a parallelogram means I know for sure the things I need to look out for is two pairs of parallel lines, okay? So this is what equivalent condition means for sure if you know that, let's say for example, I say, guys, this shape has two pair of parallel lines. Immediately what comes to your head?
Parallelogram.
It's a parallelogram. So it's the same thing. So it's same thing also. Next time the question say prove that it's a parallelogram. So if the question wants you to prove that it's a parallelogram, means indirectly they're trying to tell you that, hey, please go and find out your two pairs of parallel lines first. Okay? Prove that there's two pairs of parallel lines and then you can say that it is a parallelogram. Got it? So there is other conditions beside just two pairs of parallel lines because, right, doesn't mean that all the time you can able to prove that there are two pairs of parallel lines. Doesn't mean that all the time you can always use midpoint theorem because midpoint theorem can only be used when a question tells you that there's a midpoint. So what are other things that you can use? So other things, yes?
I think
Yes? All right, I'll continue the recording then. Okay, so what happened now? So for the equivalent conditions of a parallelogram, besides the two pairs of parallel lines, you can prove that there is one pair of parallel line. Okay, then you can also prove that there is equal sides. Meaning, right, if this is parallel to this, and you can say that the length of this person is the same as this person, then you know it's a parallelogram. Okay, now another thing is that if let's say you cannot even prove there's any parallel lines at all, you can use another one that is the opposite sides are equal. Means the length of this and the length of this is the same, and the length of this and the length of this is the same. And then hence you can say that that is a parallelogram. So these are what you need to memorize, okay, of the definitions of a parallelogram and how to prove it. All right, so we have two more questions and then we are officially done with this chapter. So the first example, right, two examples, I'll use this textbook example and explain to you what the solutions are. So over here, they tell you that triangle ABC. So let's look at triangle ABC. Okay, I have triangle ABC. Now, they tell me that BQ and CP intersect. Oh, wow. BQ and PC intersect at T. Okay. Doesn't mean much. Not really much clues that I know. Oh, but then I got juicy stuff. So I'm not going to do the one in blue because I have this super juicy information that P, Q, R, S are the midpoint of blah, blah, and blah. So that means that if I know that this is a midpoint, means I know that this person is equal to this person. That means that the one in red is also redundant. So let me go and do everything again. I have P. P is a midpoint of AB. Okay, so P is a midpoint of AB. That means that I know that this and this is equal. Next, I'll change color. They say that Q is a midpoint of AC. Q is a midpoint, so I know that this is equal to this. Ah, guys, so you see, the moment I have this, right? Guys, what does it mean already? If I know that P is a midpoint, sorry?
The midpoint theorem.
Yes, so by midpoint theorem, what can we say?
PQ is parallel to B.
PQ is parallel to
Yes, so right now we have PQ is parallel to BC. Okay, so I draw my parallel lines. So can you see, based on the red information, I know that P is a midpoint of AB and Q is a midpoint of AC in triangle ABC and APQ, right? So they state the triangle because you need to know which triangle you're talking about because there are many triangles happening. And then therefore, can you see I got two information I can form? I can say that not just PQ is parallel to BC. I also know that the length of PQ is half of BC by midpoint theorem. Got it so far? Yes or no?
Yes.
Okay, now let's move on. We have R. So R is the midpoint of, oh wow, of TC. Okay, this tiny one. So I'm going to color code, means this is equal to this. And then we have the green one, which is TB, and TB is here. And we know that this one is equal to this person, okay? Ha! So from here, what can we say already? By midpoint theorem, we know that SR is parallel to BC, right? So we know that now we are focusing on triangle TSR and TBC. We know that S and R are midpoints of TB and TC. So therefore, we can say that SR is half of BC and SR is parallel to BC using midpoint theorem. I think this green is very light. Let me darken it. Yeah. And that is the information that I have. So if you want to prove, okay, they say that prove there are parallelogram, remember? So you have PQRS. PQRS means this one. So how to prove is parallel? Because I know that if PQ is parallel to BC, okay, and SR is parallel to BC, therefore I can say that PQ is parallel to SR, right or not, guys? Agree or don't agree? Using the parallel lines.
Yeah.
Okay, but not just that, because remember, guys, just now we have two things. We need to either, remember what are the things that we learned just now about a condition of parallel lines? What are the conditions to prove that it's parallel? It's either number one, you prove that there are two pairs of parallel, right? What else?
One pair of parallel and equal sides.
One pair of parallel and equal sides. And then after that?
And opposite sides of quadrilateral are equal.
So based on this scenario, do you think it's wise to use number one, number two, or number three? Is it to use number one, number two, or number three? Can we use number one, guys?
No.
Is there any way I can prove that PS is parallel to QR? Yes or no? Can we?
No.
We cannot, right? So one is for sure out. But then we already have one pair of parallel lines, correct? That we prove using the one in black. So it means that I need one more condition that is one equal side. Is there any way I can prove that they are equal sides? I can. You know why? Because can you see here? PQ is half of BC. SR is also half of BC. And therefore, I can say that PQ is equal to SR. Agree? Who is confused? If you're confused, please clarify. Are you all okay? Yes? Anybody have a question?
Yeah.
No one? Okay. So if that's the case, we know that there's one equal side and there's one parallel lines, and therefore we can say that PQRS is a parallelogram. Ta-da! Done. Now, for the next part. For the next part, they say that show that ST is equal to 1/3 of BQ. So where's ST? Oh my, ST is here. Okay. So ST is here. This is S. This is T. They say 1/3 means 1 unit of BQ. This is Q here and this is B here. So BQ is 3 units. Okay. Oh, this is quite difficult. Let's see. What are the clues we have? Okay, do you guys remember the properties of parallelogram? When we have a parallelogram? What other things about parallelogram that you know?
The opposite angles are the same.
Okay, might not be relevant for this case. PQSR. Then can you see SQ? And then there's a T here. And then there's a PR and there's a T. High chance, what do you think, what concept we are using? Because we want ST, we want SQ, we want BQ also. Then you look at PR and SQ. We are using what concept? What is SQ and what is PR?
The diagonal.
Yes, they are diagonals. So what do we know about diagonals of a parallelogram? Do you all remember the concept of a diagonal of a parallelogram?
They bisect each other.
Okay, we know they bisect each other. What else?
Same length.
Okay. Then do they form 90 degrees? Yes or no?
No.
Yes. It's no. I'm saying yes as in yes, you guys are right. Okay. So we know that they bisect each other. So can you see I have ST already? So therefore, do we know what is TQ? Yes or no?
Yes.
So if ST is 1 unit, so I know that TQ is also 1 unit. Why? Because we know that the diagonals of a parallelogram bisect each other. Do you all get it now? Understand what is this trying to tell you?
Yeah.
Okay, next part. So we need to prove that it's 3 units, right, for BQ. But how are we going to get there? So the only way to get there is, can you look at this triangle right here that I'm going to draw out for you? We have T, S, R, B, C. We know that S is a midpoint of BT, correct? Right now, guys, from the question here, in case if you don't remember. Yeah. So from the question, we know that S is a midpoint. So I know that BS and ST are equal to each other because we know that S is a midpoint of BT given by the question. So I know that here is also 1 unit. So hence, if I know that BS is 1 unit, ST is 1 unit, and TQ is 1 unit, we can say that BQ is 3 units. Agree?
Yeah.
So isn't it BQ is 3 of ST? And hence we can say that ST is 1/3 of BQ. Shown. The end.